Hello everyone, welcome to this video on inventory management, specifically on the Wilson model with shortage, also known as economic order quantity model with back orders. First, let's get a quick overview of the Wilson model with shortage. So this model is useful in inventory management when we want to minimize costs while allowing for temporary shortages. And like traditional models, this one helps balance between ordering costs, holding costs, and the costs associated with shortages. Before we jump into the formulae, let's understand the key assumptions of this model. We assume that shortages are allowed and can be fulfilled as soon as the next order arrives. Another important assumption is that replenishment is instant once the order is placed. These assumptions make the model simpler and more practical for certain business environments. Now let's go over the main variables we'll be using in this model. We have CH, which represents the holding cost per unit per year, CS, which is the shortage cost per unit per year, CO, which is the ordering cost per order, M is the maximum stock level we can have, and finally S, which is Q minus M, which is the maximum quantity that we can have in shortage. Alright, with those terms in mind, here are the core formulas we're going to be using. First, the optimal order quantity, denoted as Q star. It is calculated using this formula. So this formula balances the ordering and holding costs while accounting for shortages. We also have the maximum stock level, M star. It is given by this formula. And finally, the shortage quantity, S, which is the difference between the economic order quantity and the maximum stock level. So what is this W terms that keeps appearing in our equations? W is the shortage cost ratio calculated using this formula. It adjusts the optimal order quantity to reflect the cost trade-off between holding excess stock and tolerating shortages. A higher W means more weight is given to shortage costs, so the order quantity will be smaller, allowing for more stockouts. Okay, now that we've covered the basics, let's apply the Wilson model with shortage to a real-world example. So imagine we have a small retail store that sells 120,000 units per year. Each unit costs $1 to purchase, and each order costs $8. The holding cost is 20% of the unit cost, and the store can handle shortages that cost $0.15 per unit per year. With these values, let's calculate the optimal order quantity, shortage quantity, and the time between orders. So step 1 is to calculate the optimal order quantity Q star. First of all, we have to calculate W, and then we're just going to use our formula that we already know. We just plug in the W we calculated and the CH, CO, and D. So the result is 4,732.864. Next, we need to determine the maximum stock level M star and the shortage quantity S. So for M star, it is the product of W and K star. It is equal to 2028.37. So the maximum stock level we will reach after ordering is approximately 2028 units. For the shortage quantity S, we subtract M star from Q star, and the result is 2704.49. So it's approximately 2705. So this shortage quantity represents the maximum amount of unmet demand we can tolerate before the new order arrives. Our final step is to calculate the time between two consecutive orders, T, using this formula. So we're just going to divide the Q star by the demand, and we multiply by the number of operating days. So we get 11.83. So the store should place an order approximately every 12 days to keep inventory levels optimal while allowing for the occasional shortage. The Wilson model with shortage is a powerful tool for managing inventory in situations where some shortage is acceptable. By balancing holding, ordering, and shortage costs, businesses can minimize overall expenses while maintaining an effective supply chain. Thank you so much for watching, and let me know if you have any questions.